Hello students, how are you? Welcome in Sri Classes by Badwe sir. We are discussing the topic gravitation. Let's see the further part of the gravitation topic. We completed the point what is meant by the gravitation, then what is the gravitational force, what is the discovery of the Newton, that means the by taking the example of the apple when falls on his head, that time he wondered and he just thought, then he concluded that one force is just attracting that apple towards itself, and that force is nothing but the gravitational force. Already we discussed this one. Now today the further part, that one is the Newton's law of gravitation. So our famous scientist that Newton's put forward one law by using the planetary motion. We will discuss that planetary motions also, that means Kepler's law. But before it, firstly, what is mean by the Newton's law of gravitation? So let's see firstly statement of the Newton's law. Newton put forward one law. Okay, what he did, he put forward one law related with the gravitation and its effects on the masses between the two objects and the distance between the same two objects. Means what? That Newton discovered this law which is depend upon the masses of the two objects and the distance between that two objects. For example, here A is the object and here B is the object, and distance between them is r. So he considered the m1 and m2 and the distance between that two objects. Okay, so let's see what is the statement of the Newton's law. So here statement of the Newton's law we will discuss, just 1 minute. That this figure shows that m1 and m2, which one? These two objects m1 and m2. Okay, these are the two objects having the different masses and they are attracted towards itself with a force that is shown by the F, and that force is gravitational force. So here statement of this Newton's law says that the two objects having the masses m1 and m2, what I am saying, that two objects having the masses m1 and m2, okay, which are kept from each other, that means separated by a distance, that is d. Okay, just 1 minute. Here, if the distance between the two objects is d and masses are the m1 and the m2, that time that two objects experience a force, and that force is what? That force is called as the gravitational force. Here you may see that F is directly proportional to m1 m2 divided by r square. So that is a mathematical expression for the Newton's law. That means Newton's law for gravitational motion. I will repeat. If the two objects, that m1 and the m2, okay, that means these are the masses of that object, which are separated by the distance d, that time F is a force acting. Okay, so that time that force is directly proportional to the product of their masses and inversely proportional to the square of distance between them. So that is called as the gravitational, that is called as the statement of the Newton's law. Students, you better know, when we will remove that proportionality sign, that time you have to take the constant, and here that constant is called as the gravitational constant, that is shown by G, capital letter G. Okay, whenever we remove the proportionality sign, that time we have to take compulsory the constant, and here that constant is capital G, that is called as the universal gravitational constant. So this is about the statement of the Newton's law. Now next one we will see, just 1 minute. Here G, what is the SI unit of that G? That is the Newton, is Newton meter square per kg square. Okay, what is that unit? Newton meter square per kg square means what? That kg is at denominator side, that's why here they give the minus sign. Okay, what I am saying, that here the unit of G is the Newton meter square per kg square. Here actually Newton meter square divided by kg square is there, but when that denominator comes at numerator, that time it become the kg minus 2, that means per kg, that is the reading of that unit. And the value of the G was, that means firstly given by the scientist Henry in the SI value. Henry, that is the Cavendish, that is the name of the scientist, and that value is the 6.673 into 10 raised to minus 11 Newton meter square per kg. Okay, so this is about the gravitational constants. In exam they will ask the question that write a note on, small note on or the short note on the gravitational constant, or they will ask define gravitational constant, or they will ask fill in the blanks what is the value of the gravitational constant. That time in 4 option they will give this value, you have to tick to the that particular option. So in question number first also it will come, in small note also it will come, that is the Newton's first law of gravitation. I hope you understood this one. Now next one is the center of mass. After that one, what is mean by the center of mass? Student, you know that some objects are there. For example, here you just see that one man, okay, just that he puts what one thing which is balanced by his forefinger. Okay, why? Because he is balancing that particular object on a forefinger at a particular point of that object. So that is called as, that point is called as the center of mass. Means what? For example, I will show you, just 1 minute. Here if you observe carefully, then that particular point here, this one is the point, and that point is what? Center of mass. So let's see the definition of the center of mass. Center of mass means what? The center of mass of an object is the point. Okay, ये क्या है? ये point है. Center of mass of an object is a point inside or outside the object. Inside or outside means what? Sometime it present into the inside of the object, and sometime it will be the outside of the object of the symmetry. That's why they are saying that it will be present inside or the outside of the object, at which the total mass of the object can be assumed to be concentrated. Okay, what they are saying, on that particular point that mass of whole body is concentrated. The center of mass of a spherical object having the uniform density is at the geometrical center. The center of mass of an object having the uniform density is at its centroid. What they are saying, the whole mass of the body is present as its centroid, that is called as the center of mass of that given object. So simply here that point is the center of mass. In short, the whole weight which is whole mass which is concentrated at a particular point of each and every object, that is called as the center of mass. बच्चों, आपने भी एक एक्सपेरिमेंट किया होगा. फॉर एग्जांपल, सम students are too much naughty and they are just revolving the notebook on a finger, like college student. So that time they are balancing that notebook on a finger point, and that point is nothing but what? That is the center of mass. So I hope you understood this concept also. Let's see further concepts. After that one, Kepler's laws are there. Okay, which one? Kepler's first law, second law, and third law. So Kepler was a scientist, okay, that means a great scientist who discovered the 3 laws of the planetary motion. Planetary motion means what? Planets are just revolving around the sun. So how the planets are revolving around the sun, that is discovered by the Kepler. That means their motion, their path, and regarding the time period also, then it's a revolution time, okay, and the distance also, and their sweeping area. And with the help of that 3-1, he put forward some laws, and these laws are the Kepler's first law, Kepler's second law, and Kepler's third law. Okay, so we will discuss one by one in this video. So first one is the Kepler's first law. Firstly, Kepler is saying that here The orbit of a planet is an ellipse with the sun at one of the foci. Now listen firstly what is meant by the foci. Ellipse is a geometrical shape like that you may see on the screen. I am again drawing. So here whenever the planets are revolving around the sun, that time that sun is nothing but one of the focus. Okay, actually ellipse has the two focus, that is the f1 and f2. So they are saying that your sun, okay, this sun, it become one of the foci and the remaining planet, that means revolve around the sun. So this one is of the Kepler's first law. The orbit of a planet is an ellipse with the sun at one of the foci. Okay. Now next one, just we will see the second law. I hope you understood the first law. Second law here. Second law is totally related with the area and the sweeping distances. For example, you may see the diagram. Sun is at one foci. A, B, C, D. These are the some points. A is a planet. Okay. First, second, third. They are mentioning here sweeping area. You may see that here highlighted this one, and this one. Okay. So Kepler's second law says that the line joining the planet, what? The line joining the planet and the sun sweeps equal area in equal interval of time. Means what? ये जो लाइन्स है, ओके, वो इक्वल एरिया स्वीप्स करती है. यहाँ जो एरिया है, ओके, फॉर एग्जाम्पल I set a one clock and at 6 p.m. that planet is here. Okay, then after 12 hours, okay, it will be here. After 24 hours, it will be here. So that is called as the equal areas in equal interval of time. Okay, so that is the meaning of that word. I hope you understood that second law is also. So second law says that the line joining the planet and the sun. Okay, here just 1 minute. The line joining the planet and the sun sweeps equal areas in equal interval of time. For example, they give the A, B and C, D are the distances covered by the planet in equal time, that after equal interval of the time. The positions of the planet starting from A to C are shown by the B and D respectively. You may see that here A, B, C, D. These are the points they use here. A, B. Actually, these are the positions, okay, for saying or for telling the equal, that mean areas in equal interval of time. That's why they used the shaded part. Okay, so I hope you understood the Kepler second law. First law is related with the sun as a one foci and planet revolve around the orbit. Second law is related with the equal interval of, that we can see that the area in equal interval of time. And now the last law, that is called as the Kepler's third law, that is a very IMP law, okay, regarding the examination. So here, that is the square of its period of the revolution around the sun is directly proportional to the cube of the mean distance of the planet. Means what? Whenever planet is revolving around the sun, that time square of time that that planet taken, okay, that is always proportional to the cube of distance. Okay, that means r is the average distance of the planet from the sun. So वो उसको डायरेक्टली प्रोपोर्शनल होता है. टी स्क्वेयर इज डायरेक्टली प्रोपोर्शनल टू आर क्यूब. टाइम फैक्टर का स्क्वेयर जो है वो डायरेक्टली प्रोपोर्शनल है क्यूब ऑफ द आर. आर मीन्स डिस्टेंस बिटवीन द सन एंड द planet. For example, here is the A and here is the sun. So distance between the sun and A, that is nothing but your R. Okay, so that is about the third law of the, we can say that the Kepler's third law. So I hope you understood this third law also. Students, today we discuss one by one that which point. First one is the great scientist gravitational, that means the Newton's law of gravitation, its statement. Okay, then we discuss about the unit, that is the gravitational constant का unit हमने देखा, उसकी value देखी. Then we discuss the center of mass along with one example also. Then we discuss the Kepler's first law, okay, Kepler's second law, Kepler's third law. In next lecture we are going to discuss the mathematical statement of the Kepler's third law. So student, I hope you understood this video. So please subscribe my channel, like it, share it to your friends. Thank you. Bye bye.